Hey everybody, I'm going to be taking this time in this lesson to be showing you how to be calculating the frequency, the period, the speed, and the wavelength of different waves using simple equations. Okay, we're going to look at this first example. We're going to try to determine the number of wavelengths using this formula that you see up top here. It says period equals time divided by the number of wavelengths. As you can see, we've been given the time already, which is 2.5 seconds. Time is always determined in seconds. We've also been given the period amount, which is 5. That goes there. So if I were to rewrite this equation, I would write it like this. 5, which is the period, equals 2.5 over y, which is the variable that I've chosen for wavelengths. Once I have this set up, I need to try to solve for y because that's the missing number. So what I would do is I would rewrite this y times 5 equals 2.5 over y times y. I'm trying to cancel out the y on this side and put it over here. So I rewrite it 5y equals 2.5. Now if I want to get the y by itself, now I will divide by 5. Sorry about that. And I will divide by 5 here, so I can cancel out the 5's and leave y by itself. So when we solve for y by itself, 2.5 divided by 5 equals 1/2 or 0.5. So we have determined that the amount of wavelengths is 0.5 according to this equation. In the video that you watched last week, you should have learned that frequency and period are reciprocals of each other, meaning that the meaning of one is the exact opposite of the meaning of the other. So in this particular case, if I wanted to determine frequency, I could say f, which is the special symbol for frequency, equals 1 divided by t, which is the period. On the other hand, I could say the period, which is a capital T, equals 1 divided by f. In this case, we need to determine the frequency, which is the missing number, when we are given the period amount. So let's give this a try. If I have frequency equals 1 over period, and period is 2.1, when I calculate 1 divided by 2.1, my frequency amount ends up being 0.476, and we use the symbol Hz for Hertz. Now I'm given a different situation where I am already given the amount of Hertz for frequency, but I am not given the number for the period. So in this case, I would prefer to use this formula because I'm trying to determine the period. I already know the frequency. So if we rewrite this, T equals 1 divided by 0.75, then we can figure out that T would equal 1.33. In this case, since it is the period, we write seconds because the period is an amount of time. Now we'll look at a different formula. This is the formula for speed of the wave. If you notice, you'll see the script F for frequency and this other character, which we call lambda. That's the letter in a Greek alphabet, and that refers to the wavelength. So in this particular case, we are given the amount for the wavelength. We're also given the frequency, and we're being asked to find what the speed of the wave is. That V stands for velocity. And the units that we would use will be meters per second. So let's try this out. If I have velocity equals my number for frequency, which is 50, and my number for wavelength, which is 0.001. If you notice, I've put parentheses around those because I need to multiply those two numbers together, as you can see right there. When I multiply those two numbers together, my velocity is determined to be 0.05 meters per second. So we would write 0.05 meters per second right there. So we have the same formula again, but as you can notice, the lambda amount, which is for wavelength, is missing. We are given the amount for frequency, also the amount of the velocity, and we need to determine the wavelength, which will be a unit that's measured in meters. So if I'm trying to determine the wavelength, I'm going to write what I already have, 45.6 equals the frequency, which is 78 times the wavelength, which we don't know. In order to determine this wavelength, I'm going to go ahead and divide by 78 on both sides so that I can cancel the 78 out of the right side, leaving wavelength by itself. Once I've determined that, this number turns out to be 0.58 rounded meters equals the wavelength. So my answer over here now will be 0.58 rounded meters. I'm given this formula one last time. In this particular case, I'm given the wavelength, which is in meters. I'm also given the velocity, which is in meters per second, but I'm missing the frequency, which is the amount that we measure in hertz. Let's go ahead and work this problem out and try to determine what the frequency is. So if I write 48, sorry for the scribbling there, equals frequency, the number I don't know, times 0.3. Now I need to divide by 0.3 to cancel out on this side and get frequency by itself. So these would cancel. Therefore, 48 divided by 0.3 equals my frequency, so when I divide 48 divided by 0.3, that comes out to 160 equals my frequency. So we write 160, and the unit that we use is hertz. Here's a bit more of a challenging one because I am being asked to find two variables in this formula. Now that doesn't seem possible to do. It doesn't seem like I have enough information, but I'm given the period amount in this particular case, which will help me find one of those variables. I wonder if you can guess which one it is. Anyway, we need to do an extra step to determine the frequency, because if we're given the period, we can use a formula that we know to find the frequency. So if I'm trying to determine the frequency, I know that it's 1 over t. So my frequency will be 1 divided by 2, which is t. So my frequency is going to be 0.5. So now I've determined my frequency, 0.5 hertz. That is a scribbly HZ. As you just saw, I determined that the frequency was 0.5 hertz by using 1 divided by 2 seconds to determine that. Once I have that, finding the velocity is quite easy. So I'm just going to go ahead and go ahead and get my pen here. Velocity equals frequency, which is 0.5, and I'm going to multiply that times the wavelength, which is 1.2. So when I multiply those two together, I'm going to determine that the velocity is 0.6, and we always write meters per second. So my velocity would be 0.6 meters per second. One more challenging one to look at, we'll go back to our frequency and period formulas. If you notice, we are given the amount of the period, which is 1.3 minutes. We are to need to determine what the frequency is. Problem is, period is normally determined in seconds, but we're given an amount in minutes. We cannot do this formula the way it's intended until we figure out how many seconds that is. So in this particular case, if I'm going to convert minutes to seconds, I need to take my minutes amount and multiply that times 60, which is the amount of seconds in a minute. That's going to give me 78 seconds. Now that I have 78 seconds, I can easily determine my frequency. As you know, frequency equals 1 over t. In this case, 1 over 78. And as I determine what 1 divided by 78 is, my amount turns out to be frequency equals 0.0128 hertz, because this is a frequency amount. So my answer equals 0.0128 hertz. And I've converted from minutes to seconds, and then I've used the formula for frequency to determine how many hertz it is. Hopefully you've gotten a chance to see the different formulas to determine frequency, period, speed, and length. You can go ahead into the next thing in Google Classroom, which is the Google form. Try to work out some of those problems and submit that Google form. Thanks, everybody.